Okay, I'm back, and now we're going to do a review of Lesson 11, which was on the Earth and terrestrial worlds. So this is going to be Chapter 7 out of your textbook. And I want you to think of dominoes, how if you have a whole bunch of dominoes lined up, and then you knock over one domino, then that causes the domino in front of it to be knocked over, which causes the domino in front of it to be knocked over. So there are three basic things that are going to influence your terrestrial planets. So it's going to be the mass of the planet, how far that planet was from the sun, and then does that planet have a large moon? So these are your initial dominoes, because the mass of the planet influences the amount of gravity that that planet is going to have. The larger the planet, the more gravity it's going to have. Also, the larger the planet, the more heat it's going to retain. Smaller planets cool off faster. And then that's important because the internal heat of a planet determines whether or not it's going to have a magnetic field and determines whether or not it's going to have plate tectonics. And the plate tectonics is important because that's what's going to produce the volcanoes that produces the atmosphere. And then the atmosphere is important because it causes erosion. It protects the planet against meteors, and then it also helps to hold water down so that that water doesn't evaporate. Then the water is important because it absorbs carbon dioxide and makes limestone, and it helps to moderate the climate of the planet, and it also makes the lithosphere melt easier so that subduction can occur easier. And then the distance from the sun, well, that's pretty easy. So the closer you are to the sun, the more solar wind you're going to experience, and then also the temperature is going to be higher. And then what does that moon do? So the moon acts as a stabilizer to keep your planet from doing this. So Earth is tilted at a 23-degree angle, and it does wobble a little bit. So it does wobble about 5 degrees this way and 5 degrees this way over millions of years. But without the large moon, the tilt of the Earth could be anywhere between 90 and this. So it could do this. And you can see how that would really affect the weather. Now, it would still occur over millions of years, but life would not be able to adapt quickly enough to a changing climate like that. You got to know why water boils. So that water can boil for two reasons. One, it gets hot. So that's what you normally think of. When you heat up water, it boils. But you can also boil water by reducing the pressure on top of it. Very important. So let's start off with the moon. So some general properties of the moon. It's small. So if we go back to here and we consider the fact that the moon has a small mass, then think about all of those dominoes and what would the moon be like. So that explains the lack of atmosphere on the moon. It explains the lack of pressure. It explains the lack of oceans on the moon. Also, without the atmosphere, remember the atmosphere helps to moderate the climate so that during the daytime on the moon, because it doesn't have an atmosphere, it gets very hot, and at night it gets very, very cold because it doesn't have that atmosphere. And then composition, I need for you to know the lunar highlands and the Maria and how did they originate. So you should know that. It's pretty much geologically dead. So no plate tectonics to speak of. Let's talk about Mercury. So Mercury is pretty much like the Moon in that it's heavily cratered, just like the Moon is. It's very small, doesn't have much of an atmosphere, so it doesn't have much atmospheric pressure, has extremes in temperature, just like the Moon. And I would like for you to know, why does Mercury have the large iron core? Okay, but that's basically it for Mercury. So let's take a break, and when we come back, we'll talk about carbon dioxide and Venus.